will be going to and we will be learning what do we call modern periodic table. Okay, we will be learning modern periodic table. And as you all know, modern periodic table, it is the mode of classification. Okay, it is the mode of classification, or it is the periodic table which we are using right now. Keep in mind, what are we using right now? We are using the modern periodic table. We have Mendeleev, we also have the Werner-Strait, we also have Newland's law of octave, and we also have the classification done by Lavoisier. They are all a very great scientists. Okay, all of them are a very great scientists, but then we don't use them. Why? Because they all have limitations, and moreover, most and all of the elements could not accommodate there. Okay, and Mendeleev also have a defect. What are the defects of Mendeleev periodic table? You can look at your study material which I provide you, and you will see all the defects of the Mendeleev periodic table. Because of all those, now one scientist, a very great scientist, come up. His name is Henry. He come up with a modern periodic table. Okay, he come up with a modern periodic table, and now we are going to study the modern periodic table. So if we look the modern periodic table, this is the modern periodic table. It is very similar with what? Yes, it is very similar with Mendeleev periodic table. So Mendeleev periodic table make a way, it pave a way for the modern periodic table to come up. I repeat again, Mendeleev periodic table was very useful. Why? Although Mendeleev periodic table was not used now, although Mendeleev periodic table was not that successful, one achievement of his is that it paved a way for the modern periodic to come up. Okay, it shows the way, it shows how modern periodic table will come up. So what are modern periodic table? Where? What is the property? What is the modern periodic law? The modern periodic law states that this one is what the modern periodic law states. It states that the properties of elements are the periodic function of their atomic mass, which means that in modern periodic table, all these arrangement, they are all done with the help of atomic number. Remember, atomic number. They are all done with the help of atomic number. But what do you mean by atomic number? Atomic number simply means that, I repeat again, atomic number simply means that the number of protons plus the number of neutrons is the atomic number. So, for example, we have sodium, and what is the atomic number of sodium? The atomic number of sodium is 11. Okay, the atomic number of sodium is 11. Atomic number of sodium is 11, and which means that the number of neutrons and the numbers of protons is 11. That's how simple it is. We also have boron, and the atomic number is 5. Okay, atomic number of boron is 5. That means the number of protons and the number of neutrons in boron is 5. It's very simple. If you see here, hydrogen 1, lithium 1, beryllium 4, and like B5, C6, all these are the numbers of atomic number. I mean the atomic numbers. See, we have oxygen here and we have 8 here. That means 8 is the atomic number. And let's recap. In Mendeleev periodic table, we have what? Period. And we also have group. Okay, we have periods and we have groups. We have periods, we also have groups. So even in modern periodic table, like in Mendeleev periodic table, we have periods and we have groups. So what is period? What are groups? I'm going to explain. Groups is this horizon, this vertical column which come down, all these are group. Okay, the vertical column which come down, this one is group, this one, all these are group and group and group and group and group and group and group, 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 and group. These are group. And what do we mean by a period? When we say period, period is the horizontal. Horizontal means which go this side. This is the period and this is the period. Okay, I am going to use, and let me use one. This is the period, this one. This one which go horizontal, which slip azal in mar, we call it azal himo here periods and so. This one which go this way, they are the periods, they are the periods. This one, they are the periods. This one, they are the periods. This line, they are periods. This line, they are periods. And this one is the group. This which go down, they are groups. They are called groups. They are called groups. Groups, group, groups, 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 group. They are all groups. Okay. And now, how many group did we have? If we say how many group we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And also I'll count it again. We have 1 group, we have 2 group, we have 3 group, 4 group, 5 group, 6 group, 7 group, 8 group, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have 18 groups. Remember, I'm going to write it here. Group is 18. We have 18 group. And also I am going to use, we are going to count the number of periods. We have 1, 2, 3, okay, 4, 5, 6, 7. And that means we have, how many periods? We have 7 periods. Okay, this one is what we will know. That means we will have, in modern periodic table, we have 18 groups and we have 7 periods. In Mendeleev, how much we have? We have very less. Just look it back, you will see it. Okay, so now we learned something. We just learned something. That is the difference between modern periodic table and Mendeleev periodic table. What is the difference? In Mendeleev periodic table, they are arranged in order of their increasing of atomic mass. Okay, atomic mass, the mass of the atom of an elements, that is atomic mass. They are arranged according to that in Mendeleev. But in modern periodic table, they are arranged in order of their atomic number. See, in their increasing, annum tanda in Nigerian school, that one we don't follow. We follow it a very, very proper way, that is in their increasing order of atomic number, like 1, 2, 3, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, 10, 11, 12, 13, 14, 15, 16, 17, 18, like that. They are arranged in order of their increasing atomic number. Like 1 will be the first one, atomic number will first, after the 2, after the 3 will come 4, increasing. That means they are arranged very properly. They are arranged in their atomic number. So that is the advantage, okay? And moreover, this period, this group number, mostly from group number 3 to 12, they are known as the transition elements. They are called the transition elements. They are called the transition elements. Okay, this is the transition elements. Group number 3 to group number 12, they are called the transition elements. So that is the difference. This one, group number 3 to group number 12, they are called transition elements. I'm going to write it again. Group number 3 to group number 12, they are called transition elements. They are transition elements. In Mendeleev periodic table, what are transition elements? I am going to go back a little bit. In Mendeleev periodic table, this subgroup B are called transition elements, right? Subgroup B. We have group A, and that group is divided into group A and group B. And that group B are called the transition elements in Mendeleev periodic table. But whereas in modern periodic table, what are transition elements? Transition elements are not subgroup A or subgroup B. They are group number 3 to group number 12. And what are representative elements? Representative elements are group number representative elements are group number 1 and 2, and group number 13 to group number 18. I repeat it again. The group number 1 and 2, group number 13, 14, 15, 16, 17, 18, they are representative elements. And group number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, they are transition elements. And in class 10, we will not be studying about transition elements, so you don't have to learn this. Okay, we are not going to study about transition elements, and that's why you will not learn this. We will just learn the non-transition elements, and also the most important is group number, atomic number 1, 3. 1 to 3. This group, atomic number 1 to 3, they are very important. Just learn it there. You need to learn this in class 10. Compulsory you need to learn this, and all the other you don't have to learn this. Okay, they are not that important for chapter 1. There are some which you need to learn, but then I will inform you later. But for now, they are not that important. You don't have to learn and memorize your atomic mass and atomic number. You just have to learn this atomic number 1 to atomic number 23. Okay, 1 to 23. So I will repeat again. Please memorize the atomic number and atomic mass and atomic number from 1 to 23. Okay, then one thing, what if these are transition elements? Okay, wait. If these elements are transition elements, okay, if these elements are transition elements and the other are representative, okay, what about these elements, this series? They are called, the first one, this one, it is called lanthanides. Okay, all these are called lanthanide series, and this one they are called actinide series. Okay, first series is lanthanide series and this one is actinide series. Okay, and then the first series is from atomic number 58 to 71, they are lanthanide series, and from 90 to 103, they are actinide series. From 58 to 71, they are lanthanide series, and from 90 to 103, they are actinide series. So the question which arises is why? Why are these lanthanides and actinides placed separately? So now, I will answer your question. We place lanthanide and actinide separately because there will be this one, the shape will be disturbed. Okay, the shape and arrangement of this particular atomic periodic table, it will disturb. It will be undue sidewise expansion. Okay, there will be uneven arrangement. The arrangement will be disturbed and the shape also will not be nice. And because of that, we keep lanthanide and actinide series separately. I repeat it again. See, everyone wants to be beautiful. Everyone wants to be nice and handsome. Okay, we are buying new dresses. We spend thousands and thousands and thousands in dress, right? We buy, in a year we spend many money. Like we are spending thousands just for dress. One shoes for just one clothes, we are spending thousands and thousands for dress. Why? Because we want to look nice in front of other. We just want to make our own status, and likewise, and people will want to look us more if we have a better night dress. And that is what happened here. Just that, if in order for that there will be no sidewise expansion, okay, because of that lanthanides and actinide series is there. Okay, they place it separately. If they don't place it separately, that means, this thing is very, why they place it separately? To avoid sidewise expansion. Point number 1, I will write here. Point number 1 is reduce, or avoid sidewise expansion. Okay, to avoid to reduce or to avoid sidewise expansion, undue sidewise expansion, it should be like that, to avoid undue sidewise expansion. And then that one is the first option. And the second thing is that if they are kept in the periodic table, okay, if lanthanide and actinide are kept in this one, in the period, if they are included here, there will be the arrangement of the modern periodic table will be disturbed. Okay, it will be disturbed, and because of that it is kept separately here. Okay, and if it comes for 1 mark in your exam, why are lanthanide and actinide series kept separately below the modern periodic table? I repeat it again. Why are lanthanide and actinide kept separately in below the modern periodic table? If it comes to a question like that, you can simply say to avoid undue sidewise expansion. You can say like that. I repeat it again. To avoid undue sidewise expansion. That is okay. Now I think you already know it. Now from period, I'll just shortly explain. For elements, number 2 has helium, hydrogen and helium. Helium is a noble gas, and the second period has 8 elements, that is from lithium to neon. They are called short periods. And the third period has 8 elements, that is from sodium to argon, that is they are called short period. And from the fourth period they have potassium to krypton, then we call it the long period. And from the fifth period we have 18 elements, we have rubidium to xenon. And also from the sixth period we have 32 elements, then we have cesium to rhenon. And then from the seventh we have 28 elements. So wow, 28 elements. We have francium and to atomic number 40 called incomplete periods. Okay, in the seventh element we have 28 elements, that is from francium to atomic number, that is that is called incomplete periods, because the period is not complete. That is why it is called incomplete period. Just see here. Yeah, this one we have francium, we have this, we all have this, we have this till 30, and this one is now blank. Okay, it is not complete. Because of that we call group number period number 7 as incomplete periods. And then also from group number 14, that is La to Lu, you can simply say Lalu, that is called lanthanides. They are called lanthanides. And then from the 7 Ac to Lr, and we have actinides. Okay, that are not that important. The thing which you must learn that are important is that this one, lanthanides and actinides, are they can sit in 1 mark. 1 mark question can come from lanthanides and actinides. What is the first element in lanthanide? What is the fourth element? And the which are the atomic number? From which atomic number to which atomic number is lanthanide series? From which atomic number to which atomic number is actinide series? What are lanthanides and actinide series? And why are they placed separately below the periodic table? Those questions can come. And then this thing they mostly don't ask in board exam. From this thing they don't ask. Yeah, from here it is important till group 20, and other that this one it is not that important. Okay, that it is not that important. And what it is important, as I said, is lanthanide and actinide. You must know each and every detail of them. There are some points, only some points. From which atomic number to which atomic number does lanthanide starts? It started from lanthanide started from La to Lu, and it started from atomic number 58 to atomic number what till that it start, I think 71, like that. And likewise you then actinide started from elements LAC to elements LR, and it started from atomic number 93 to 103, and all those things you can simply learn. I mean 90 from 90 to 103, like that you can simply learn, and that is very much enough in that in these slides. For these slides, enough question. Also you need to learn the number of periods and the number of groups. Okay, now I already explained all of this. let me explain it a bit for you again. Group number, in Mendeleev periodic table, okay, this subgroup A, they are called normal elements or representative elements, okay, and then subgroup B, they are called transition elements, okay, transition elements. Okay, and group 1 they are called alkali metals. Group 2 they are called alkaline earth metals. Okay, group number 17 they are called halogens, and group number 18 they are called noble gas. What are noble gas? Noble gas elements are the very stable elements. They are very stable and they don't have free electrons. I repeat it again. Group number 18 elements, they are also called zero group. And why are they called zero group, or why they? Because they are all noble gas. What do you mean by noble gas or inert gas? It is also sometimes called inert gas elements. Okay, it is sometimes called inert gas elements. Why is it sometimes called inert gas element or it is called noble gas? It is because, okay, I'm repeating, it is because they are very stable. They're very stable. They don't have free electrons, okay, and they qualify the doublet as the octet rules, okay, the doublet and octet rules, okay. They are a very stable elements. That one though I will simply explain to you later. What are doublet rules, what are octet rules, just know it for now. Okay, now I'm going to go to the next explanation again. Before that, I already explained for 21 minutes, so okay, let it be enough for today. We will try to. Okay, then I won't have time to do revision class with you again. So if you want to continue the revision class, please send a message to me. We want a revision class, or else if you don't want to have a revision class anymore, then I will be doing with you some important question. Okay, some important question we will be solving in the next class in Tuesday. That is the routine as they sent it for me. Okay, and then we will just end the class like this. If you want a revision class, please inform me. So these things are all. Thank you. Okay, very important. Thank you. Do your homework. Okay, I'm preparing a lot of slides, but then I think it is not. I don't have time to explain. Okay, let me do briefly. We already take the class, so you must understand is what is a valence electron. Please understand what are valence electron. You need to understand that. Look at your book. If you don't understand, call me. I will explain it to you personally. Okay, what you need to know is what are valence electron, and after that you need to know what is valency. What are VALENCY? What are valency? You need to know. You need to know what is VALENCY. You need to know what are valency. Valency, you need to know that the definition, and also you need to know how to find valency. You need to know how to find valency. You need to know how to find valency. Clear? That is important. It won't come in exam, but it is very important for the topic in the later class. And also you need to know the atomic radius, atomic size, and how it decrease and how it increase. Okay, and also coming to the next metallic property, you need to know what are metallic property, what are electropositive nature, and how it increase and decrease in a modern periodic table. You must know that. And coming again in non-metallic property, that is electronegative nature, you also need to know what are electronegative and what is non-metallic property, and you need to know how they are increased in a period and how they are decreased in a period. And I think that is important. And you must know oxides of metals. Oxides of metals, they are important. They will set question from oxides of metal, particularly from chapter 1, but then it will come from around chapter 6 or chapter 5 or chapter